Hello and good afternoon everyone from Leoben in Austria. I hope you all do hear me well. Welcome back to our online lecture series, Sustainable Development Approaches in Engineering Research and Education, where we want to connect you with leading experts, share insights into new discoveries, and connect you to a global platform. My name is Anna Wojka, and in today's session, we will dive into the topic of measurement and digital analysis of mining processes. And next week, we will learn more about the emerging role of robots in mining. Now, it is my pleasure to introduce you to Dr. Philipp Hartlieb, Senior Scientist here at Montanuniversität Leoben. His research focuses on rock fragmentation and excavation technologies, as well as the efficient acquisition, use, and analysis of data in mining processes. Today, he will give us an introduction into the use of data and measurements in mining processes, including the acquisition of data and its useful interpretation. In addition, based on case examples, he will share with us how data can drive decision-making processes and increase the economic and ecologic efficiency of a mining or quarrying operation. Please join me by welcoming Dr. Hartlieb.
Well, good afternoon, everybody. It's a pleasure for me as well to be here today and give you this interesting lecture in a series of lots of different and very interesting talks. For the beginning, that's title slide. You already know that. Anna was so kind to introduce me, and I'm not sure whether you see my screen. Yes, you see my screen. Yeah, okay. Anna was so kind to introduce me. I think there's nothing to add there anymore. I'm here for almost too long time now, the chair of mining engineering, dealing with all kinds of mining operations, fragmentation mainly, but fragmentation leads to downstream processes, leads to the analysis of the mining process in total, and that's where we're going to also with this lecture. So digitalization is an aspect to knowing your mining operation and to knowing what you're doing in total. Well, it is a lecture, so I have some objectives for the lecture as well. Just two of them, don't be afraid, they're not too many. First of all, have knowledge about the data a mine produces. So what kind of data can you actually acquire? What's the use of that kind of data? And number two would be to be able to define and evaluate the need for KPI-driven data collection solutions. So why do we want to collect data? What do we do with the data? What kind of information do we get from that data? And that's the main objective of today's lecture. For the start, I brought you a quote, which is, I don't know exactly how long, but a bit more than 100 years old, which was done by Lord Kelvin. He said, when you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. I think that says it all. Kelvin wanted to measure temperature and some other things. In modern times, well, temperature is a low-hanging fruit. We can measure many other things, but we want to know something about the process. We want to know something about the background, and that's the reason why we are measuring things, and that's, well, the overall goal of what we are doing and how we can define things. Well, a gut feeling is in many cases very good, especially if you're a very experienced mining engineer. I think many of the more experienced guys in the audience will know that the gut feeling does not disappoint them too often. But what we know or what we can measure is still something that is probably of more value or of more sustainable value. Let's take a look at the mining process. So the mining process, well, I think you know it roughly, or you should know it roughly. I think there are some non-mining engineers in this audience as well, if I understood right. So let's try to recapitulate that a little bit. On the first hand, of course, you have the geology. The geology is what you're dealing with. The geology is, the material that you're working with in the end. From the geology, you go to the blast site. So the venue where you're blasting, the venue where you're fragmenting the rock and having the first real mining step. So from where you're progressing. From the blast site, you go on to the muck pile. Lots of information can be gathered on the muck pile. You can gather the shape of the muck pile, how long it flies, so how long how far the fly rock distance is, how the fragments are oriented, how the fragments size distribution is. So lots of information that you can gather from the muck pile. Then what happens next after the muck pile? Of course, you have to load it, you have to gather it, you have to move it around. So that would be the loading stage. You want to know something about your loading operation. You want to know how efficient that is. From loading, of course, there's hauling. In many cases, hauling or conveying. You want to know how the hauling process is, how efficient that is, how far the distances are, what kind of altitude change you're having, how the road conditions are, lots of things that you can measure. And for today, we're going to stop the mining process at the primary crusher. So it's crushing. The first crushing step probably can be included into the mining process, depending on which side of the table you're sitting in and how you want to discuss that. But we go until crushing today and say this is the integral part. So we want to know something starting from the geology on the top left side in this picture, going down all the way through the blast sites to the muck pile, to the loading operation, to the hauling operation, and last but not least to crushing. In the end, linking geological data with the energy consumption, for example, in the crusher that you have, or with some kind of quality control that you might assay in the crusher. To do that, I prepared a little Mentimeter survey for you. I want to know from you, and I have to change my setup a little bit. I want to know from you what you would like to measure in a mining operation. So for doing so, I think you're all familiar with Mentimeter. I would ask you to go to the webpage that is highlighted on top here. It's menti.com. And please insert the code that is here, 67176010. And I reserved up to 10 spots for you to, well, type in your thoughts on what can be measured in a mining operation. Just to give a bit, to acquire a little idea of what you would think of. So I purposefully did not mention too many of the things in the previous slide. I want you to think of some, and then later on, of course, we're going to discuss those. So let's start revealing that, and I hope that a couple of more will fly in on the way there, because all of you are going to hit the submit button now. Let's see, what do we have there? Okay, that's a huge group here. In the center, what do we have there? Productivity. I think many of you put in productivity. We're talking about stripping ratio, we're talking about the rock size, the weight, the position of the truck, production rate, the volume, vibrations are very important, yeah. The bench width, wow, now it's getting too tiny, so many points there. The grade, ore grade, bench height, noise, transportation distance, haulage distance, yeah, time, and many more. So I see that you have a very wide variety of options there, and good knowledge also of the mining process, of course. Somebody mentioned the idle time, which is also very important. It's a matter of productivity, how long your truck is idling and how long it is moving. So let's go a little further. Thank you for your input. Let's go a little further back to the slides. I hit the wrong button there. No, okay. You see, I have a list here. Of up to 5 slides. No, 5 slides. Yeah, with lots of different data. So data that I compiled from different literature sources, trying to show you which kind of data you can measure and what you can get. And I try to distinguish also between data that are measured automatically, data which are kind of low-hanging fruits, which you can get easily, and data that are in many cases measured manually. And if you have manually measured data, your operation or your mine manager will consider very carefully whether he really or she really wants to measure those data, or whether they don't want to have the data because they are a huge effort of gathering them. Is this a full screen? Oh, sorry, something happening there. So that should be full screen. Sorry for that. So what you can see there, and I won't go into all the details, but I think many of the things that you also mentioned in your list previously, I mentioned here. So from the amount of explosives, which can be measured automatically, to the back break, which is important for a blasting engineer, for example, to the burden, to the condition of the borehole, borehole wall. Delay timing is a very important part. Then there are some other very specific things, which are the diggability. So how easy is it to dig into this muck pile? I think that's something that in literature many people are discussing, and nobody really knows what it is and how to define it. But at least you can defer the loading time, the time it takes for digging one bucket and going into one bucket. We do have fly rock. The force is acting on the boom of excavator. We might have, speaking of sustainability, a very important part, which is the fuel consumption of your equipment. We do have geochemical compositions, geological structures. That's the first very tricky one. So how do you really assess geological structures in a numerical way? So that's something that we can measure, that's something that we can map. But how do you transfer those geological data into your mine management system, into your digital evaluation system? That's something that we need to discuss a little afterwards. You do have GPS coordinates. You can measure the height of the muck pile, idling time of crusher, the track of an excavator if you wish, length of the drill holes, so many things. Operator fatigue is also something very important. And yeah, I think you will get the PDF of those slides afterwards. There's nothing, it's no sense really going through every point here, but I just want to make you aware that so many out there and everybody is having a different opinion on what's really crucial for the operation and what's really crucial for their success. So in the end, you could basically measure everything, and you could discuss, well, everything in this context here. So let's go to what's next. When you ask, and I have to admit I didn't follow the talk last Thursday about the colleague of St. Petersburg University, but when you ask mining engineers, why do you do data analysis, why do you do that kind of stuff, the number one point that's popping up here would be automation. People don't really want to know something about the operation, but they want to automate the operation. So they collect data so that automated equipment can move in their mine, or automated equipment can dig or do something else with that. And if you go on the bottom side here, it's going along with automation. You have artificial intelligence there as a very important topic. You have machine learning there as a very important topic. I think they're all going hand in hand. So without artificial intelligence, without machine learning, also the automation approaches might not be that successful. But of course, if you take a look at this plot, there are many other aspects that these mining engineers that have been asked for this study, and this is a study from last year, from 2020. So the many aspects that those guys have identified as a goal or as the incentive of doing digitalization in the mining operation. So why they do this and why this is important for them. Some of them, if you take a look at the top side here, you have the virtual reality mine training, you have video analytics, data analytics. There's many important and interesting points, but I think automation is, for many cases, the top goal. Going one step further, if you take a look at this one, doesn't move, just moves on my side. Just slow. If you take a look at this one, this is the Industry Digitalisation Index published by McKinsey Global Institute. What it basically shows in green to red is how well digitized an industry is. When you take a look at the top lines here, you have ICT, you have media, you have lots of professional services. But when you take a look a little deeper, so mining would be here, in this line here. Mining is red in many aspects. Mining is not well recognized as a highly digital operation. So the only points where it's really highlighted is green. The green would be this line here, and all the rest would be red. Green would be transactions. So how we pay our customers, also how our customers pay us, or how we pay our suppliers. So they will be happy that that's digital, but all the other aspects are not considered or conceived as being so digital in the mining operation. So I believe that we have still a long road to go to fully implement digitalization in the mining operation and implement that in a meaningful way. That's, I think, also a very important aspect there. If you take a closer look at just mining operations, this graph shows you how well digital aspects are implemented in the mining industry globally. And you can see that the top part, I think, is with 14%. It's digitalization in the public relations sector. Here in haulage and automation, you do have some digitization aspects. The last column here, going down there, the VR training, nothing there. Social media, okay, a bit. Exploration, this line here. This line here is exploration. You see that it's just a little bit backed by digital technologies, and all the rest is just below 5% or 1%. So I think that's in line with what we had on the previous slide, that there's still huge potential for the mining industry to push their digitalization aspects and go one step further, trying to be on top of the game of that development. But at the same time, I also know there are many initiatives nowadays towards digitalization in many different aspects, be it from, as we said, automation and haulage, to rock fragmentation analysis, to the entire system integration. So there's plenty of things also going on, and I believe that in a couple of years we will not be as perceived, at least, as so low digital, if this is a proper English word. This is another graph taken from literature. It's mainly showing where can we along the value chain implement digital solutions. And for us as a mining engineer, I think this part here on top would be the most interesting part. It would be, in mining and beneficiation, so it would be in automation, digital and remote operations, that kind of stuff is where people can see that mining operations shall be digitized and that mining operations will be digitized in the future, leading to a successful mining operation. So going back to the data a little bit, we indicated that also on one of the previous slides. There are data that we can measure comparably easily, and there are data that we cannot measure that easily. Data that we can assess by looking, that we can describe, that we can probably draw on a graph, draw on a map, but which are not data points in that sense. So we distinguish between quantitative data and qualitative data. So quantitative data, if you take an exact look at that, can be expressed in numbers, it can be measured, and it can be compared quite easily. Qualitative data, on the other hand, cannot directly be expressed in numbers, can be compared verbally. So you say this is nicer than the other one, but that's not a very technical perspective. And in many cases, this qualitative data can be transferred into factors, so factorized. As at least 50% of these audience are mining engineers, the RMR, for example, would be a good example. So the RMR is the rock mass rating. For those who are not so familiar with that, it's a rating considering how the rock mass in total is structured, how the strength is, how cleavage planes are oriented, how much water is there, how slippery it is, so which technical parameters you can verbally describe, and which will then be transferred into this would be a semi-qualitative way of doing that. So you have a description of the rock mass, you have some values of the rock mass, and you transfer those into a number. In the case of RMR, it would be between 1 and 100. And this could be valid for many other data points as well. And this is a very important aspect, so that you also know how do you incorporate your qualitative data into whatever you want to do. If you think back to the second picture of this lecture where we had the geology, then the blast site, then the loading and haulage, and crushing operation, the geology would be a classical qualitative data point. In many cases, you can get the geology with automated chemical analysis. Then you know something about the geochemistry, you know something about the value that is in there, also about the rock type, because this is directly inferred from the chemistry. But you don't know so much about the structures. You don't know so much about the fault planes, about cleavage planes, about whatever is in their cavities. So that is a nice example of that, of qualitative data. Then, building from that, you might have structured data and you might have unstructured data. So structured data is when you're really sitting down and consider what do I want to have, how do I want to assess that, how do I want to measure that. So you build a deliberate structure and a scheme and follow that one. So you really follow that scheme and fill in your data, and then you have it. Unstructured data is, well, as it says, no structure. You cannot recognize unstructured data so easily by a computer. Coming back to the geology, for example, it is collected in a more natural way. So by the way you go through a mine, for example, and say, okay, this is something happening there, and there's something happening there, and then you write that down or you assess this in some kind, but it's not in a fixed scheme. And then when you want to take a look at the data, you cannot go through that data that easily. You cannot query this so easily. So you really have to consider how you evaluate the data and what you want to have from that data. It might be okay to have unstructured data. It might be okay to have, hopefully there are not too many geologists, but because I don't want to be rude, but it's complicated to assess, for example, the structure. So if you have many graphs, if you have many maps of your benches and how they look like, it's also okay because you can interpret them, but the machine has a hard life interpreting them. So that's the thing about the data and how you use them and how you structure them. When you take another view on data, you have direct and you have indirect data sources. Direct data sources would be those that are really deliberately built to measure something. So direct data in this graph is just the top left quadrangle. So for example, you have satellite data, satellites that are deliberately measuring how the surface of the Earth is behaving. You have a price, you have GPS coordinates, which are really used for having those coordinates. But then you have lots of indirect data. Data that you measure or that you assess because something else is happening. Safety conditions or the working position would be something that is indirectly assessed by humans. You have indirect assessment or indirect data from the processes. So from the drilling and blasting process, this is the process that you're doing anyway, but you can measure the drilling and blasting process. You can measure torque on the drill rig, the pressure on the drill rig, the forces acting on the drill rig. That would be indirect data because you do the drilling process anyway. Same for a conveyor system, same for the haulage system. Or whatever you have there. So you have to move your truck anyway, and then you can measure data that are on the truck or that are gathered on the truck, from the fuel consumption to the speed to acceleration in set direction, and so on and so forth. And similarly, you can also assess or gather indirect data from all types of assets and machines that are situated in your mine or operational in your mine. So this is where data normally comes from and data that you can use. But consider this graph and you see how vast the availability is. So it's not just what you mentioned in the beginning, that you want to know something about your productivity, that you want to know something about the ore grade. You have a huge portfolio of options there, a huge portfolio of opportunities. And you want to and then it's up to you, and probably also machine learning, to assess that data and see what is really aligned to one another, what makes sense, how do I combine these data sets in order to make them valuable for me. Just measuring them doesn't make too much sense. You have to do something with them. Otherwise, yeah, it's a nice exercise of measurement, but it's nothing else. But we will come back to that a little later again. Come back to that with key performance indicators. So that's the second important aspect that I want to discuss in my talk today for the next 15 minutes before we close this lecture again. I want to discuss about key performance indicators because they are the value. They are what you generate out of the data. The first thing is measuring data, collecting data, but the second thing is doing something with the data, as I just mentioned previously. So if you want to define a key performance indicator, that would be a set of measurements focusing on those aspects of organizational performance that are critical for the success of the organization. So you have to define what is critical for the success of your organization. What do you really want to find out, or what do you really want to analyze with your data? And that's, I think, where we are. And I will come back to Menti again with hopefully the next slide. Yeah, because I want to know from you which kind of KPIs are important for a mining operation from your perspective. What would you want to find out? I defined here on two, also taken from literature and other considerations, 2 slides, what kind of KPIs well, you can think of. Well, of course, indicators related to a mine's organization. So is the mine well organized? I think this is one of the important parts. Then from a more technical perspective, for example, the degree of blockage or degree of starvation. Then, well, the process planning, the net present value of a mine. So how valuable is your mine? What is the earnings, the income, the costs? Then we already had that, quality indicators, indicators related to the loading and transport and haulage systems. What I also mentioned earlier is the energy consumption, of course. Carbon footprint would be something. Specific water consumption could be something. Effectiveness in total could be something that you're interested in. Maintenance, operations management, and, well, productivity. So bucket fill factor would be a very nice, it's just a value in the end, but it would also be a very nice KPI to have. The loading conditions could be something. The cycle times could be of interest for you. The quicker your cycle times are, normally the more productive you are. I hope that's the case in most operations. What you can also think of from the technical perspective is productivity, so the length that you mine, the tons that you do per hour, the kilometers or meters that you do per shift. Yeah, overall efficiency. What else do we have there? Yeah, the performance of miners of surface or road headers or continuous miners that you have in your operation. Shuttle car utilization when you're talking about underground operations. We already had transport time, time to repair, the entire LHD machinery. Very important, machine availability and utilization. I think that's also something that you mentioned in the first word cloud, saying the idling time, spotting time, that's what we have there. And I think last but not least, also a look at the employees. So how is the working time? How is the idling, the running time of machines? How is the fuel consumption and the electricity consumption? But that's just some ideas. So we do have, what did we say, 88 people in the audience here. So everybody will probably have a different view on that, depending on where you're operating, which kind of operation you have. So yeah, I'm just giving some ideas, but you have to define on your own. When you take a look at how mining companies see KPIs, you see here a table also from 2020, which kind of KPIs different of the large mining companies measure and assess. So some of them, I think it's only Rio Tinto here, assess it as a KPI, the business ethics and business transparency. So we are, I'm a technician, so I'm not so much thinking about that when gathering data, but it's also a very important point for many for many operations. Some of them are measuring community relations, which probably also linked to business ethics. Many are measuring environment, so how is their impact on the environment, and of course they are, measuring health and safety. What I'm a bit surprised is that if you take a look, for example, here at the line of production, there are BHP, Rio Tinto, Glencore, and Vale don't seem to measure their production. So I don't believe that, but probably forgot that they are producing a mining company or so. I don't know how this survey was made and how the authors of this paper came up with the information there. But definitely, this is also what's interesting for me, as I said, as a technician, that there are many more aspects to the mining operation than just the production. There's so many environmental influences, social influences that you also have to consider, and I think that's the important learning also here that you, can think of. Some other KPIs, as I said, we don't go through the whole list, but you can go through maintenance, everything that is associated to maintenance, the number of teeth that your haulage, that your loading equipment is taking, the number of peaks that your continuous miner is consuming, fuel consumptions, that's all, not fuel consumption, the number of tires that you're spending, that's all, would all be maintenance. You have KPIs on the financial part. You have KPIs, many KPIs on temporal part, so timing, as we repeated several times now over the last 40 minutes, timing, so idling times, spotting times, loading times, digging times, whatever you have there. Then safety, a very important aspect for your operations. The less fatalities you have, I believe, the better this would be. And some of the physical characteristics, of course, of your ore and that you can think of. So let's see if this moves on. When you take a look at that on a different perspective, we have had the technical parameters, we have the temporal and the spatial parameters. We mentioned mainly temporal, technical and temporal parameters in the previous slides, but spatial is also very important. The elevation profile, for example. So how high do you have to go? So with the full haul truck, do you cover 10 meters, 100 meters, or 1,000 meters of altitude change? It's a huge difference in fuel consumption and efficiency. Your slope angles, your travel distances, they all play a role there when you take a look at those KPIs, and they're equally important. So, the thing is, we do measurement, we define KPIs, and as I said, we have to do something with that. And I believe this cycle shows it very well. The first step that you see on the top side here is you define your KPIs. You define what is valuable for your operation. What do I want to find out? Second step is you collect the data and store the data, of course. In many cases, I believe it's also the other way around. First you collect the data and then you want to find out what to do with it. But in the ideal case, you first want to find out something, then you collect the data. Then you validate or analyze the data, validate the data, and from there on, you have a feedback loop to step number one. Because, measuring that once doesn't make any sense without real improvement and without really showing what you could do with the data and what you could do and how good this is for your operation. Just one example. I hope you can see that it's many data points on a small screen for most of you. But just the value of a truck, if you want to discretize that in so many different points. But the tons that you haul with a truck or with trucks in total, it will depend on the number of trucks. And as you can see, the number of trucks is the only thing here in this graph which does not have a further daughter. So then you have the operational hours, you have the load, you have the cycle time, and from there onwards you can design many aspects of the value of the truck. How good is it working? Do I need an additional truck if you go to that number of trucks slide here? Or can I use the trucks that I have more efficiently? Could I even reduce the amount of trucks that I have when I do something better than I did before in that respect? So this shall show you the huge variety that you have when you take a look at the data and analyze the operation in real detail. This is when you go back to slide number 2 or 3 or 4, I don't know, in the beginning, you can link all those data points that we had in the beginning. You can link them. You can defer any type of KPI, any type of measurement, any type of analysis, any type of graph from that. What I tried to put here is very arbitrary numbers. For example, would be something that you have in this slide here. You would have the geology, which would be, well, qualitative data combined, for example, with the kilowatt hours of energy consumption that you have in the primary crusher. That might be one thing. Saying, okay, I do have a very complicated part that I'm working in now, energy consumption should be higher. I change my blasting layout, energy consumption should be lower or higher or whatever. When you go to the other graph that I plotted here, you can fuss around or play around with the loading time, with the grain size distribution, which is expressed at x50 here, with many other aspects, and try to see what is really making a sense in your respect. Just as an example, I got to read a manuscript 2 or 3 weeks ago where somebody was comparing the digging time and analyzing the digging time of a wheel loader into the muck pile. The difference in the digging time was marginal. It wasn't a couple of half seconds or seconds, depending on the difference in the muck pile. But if you take a look at the entire mining operation, and if you have 10,000 digging events a day, half a second doesn't really count, because then you have moving backwards, moving forwards, dumping on the truck, spotting, idling, preparing your muck pile. So you have so many moving between different muck piles if you do quality control. So it was a very academic work, and they could nicely show, for example, what's the differences between those muck piles. But I think from a global, from the company perspective, the value is not that high in that analysis. So you really have to think of what you are doing. And this brings us to the last 2-3 slides of the lecture. Just 2 examples of what kind of data is meaningful and what fits together. So what I show you here is a plot of a campaign that we did on our own. So we tested, you see that there, detonators, we tested electronic detonators, and we tested electronic calculators in a specific setup. Okay, so we didn't just take 33 millisecond electronic detonators. We made one detonator with 12 milliseconds, one with 20, one with 33, one with 15. So we wanted to test something there, okay? And the theory is that your muck pile has different characteristics afterwards, and those different muck pile characteristics lead to different downstream characteristics. Well, if I take a look at that graph, I don't see those. So we fussed around a lot with the data, but we didn't achieve too much, to be very honest. But that's something that you have to consider for yourself as well. What do I want to find out? Is it significant? Is it not? In this case, for example, we could change the vibration level. That was significant for us. That was significant enough. But we also wanted to show whether there is an influence on other downstream processes with changing the explosives parameters, and in this case it wasn't. So the mission was partly accomplished, at least. Another example of other authors here, you see the production time on the x-axis is both time is the production, the productivity, so buckets per hour, and here you have tons per second, which in the end translates to the same thing. And on the left graph, you see the percentage of fines. So how fine is the material, and on the right-hand side, you see that the oversize. So these authors demonstrated that when you have much or a high degree of oversized material, your productivity will go down. Equally, if you have a high degree of fines, your productivity will go up. I'm not so sure whether everybody would back this statement, but at least that's what this evaluation has shown. Well, on the other hand, if you take a look at the scalar here, okay, so the regression graph is probably not that that confident to really plot that. But that should show you what you can achieve with the data. So I don't want to judge the results here. These are just examples. I just want to show you what you can achieve with the data and what you can, well, defer and analyze. That's the real goal here. So last but not least, summarize the lecture shortly. I have two major takeaways considering or being in alignment with the very first slide on the objectives of the lecture. So the first takeaway, something that you might want to consider, is what's the goal of measurement and data collection? So why do you want to do that? What is your personal goal? What I have here are just a couple of examples. You want to have better insight into the mining process. You want to probably want to have good fleet management. You want to improve your KPIs, whatever KPIs those are. You want to improve health, safety, and environment and sustainability of your mining operation. Just some of the examples, but that's, I think, one of the important goals. One of the important aspects is consider what are your goals. What do you really want to find out? Because otherwise, yeah, you're just measuring. That's not the value of it. And last but not least, define the term KPI. So that would be some of those who've already taken lectures. I said, sorry, an exam on that. KPI, just to recapitulate that, would be a set of measures focusing on those sites for organizational performance that are critical for the success of the organization. If you have a dashboard full of KPIs and much too many that you can read them, also then I believe you will not be able to focus on those that are really critical. So you have to identify the critical path of your operation, the critical steps in your operation, and then you will be successful, hopefully, in using the data in a good way. With that, I am at the end of my lecture.